Today we've got some fascinating news from the world of space exploration. We're diving into the mysteries of Pluto, specifically the famous heart-shaped basin known as Sputnik Planitia. Pluto's iconic heart-shaped feature, Sputnik Planitia, has puzzled scientists since its discovery. It's not just a pretty face. This giant structure on Pluto's surface seems to be incredibly heavy. But why? Sputnik Planitia was first spotted in 2015 by NASA's New Horizons spacecraft. This vast region, roughly the size of the Democratic Republic of Congo, lies 3 to 4 kilometers, 2 to 2.5 miles, below Pluto's surface and is filled with frozen nitrogen. Dean Denton, a researcher studying this phenomenon, thinks it's an impact basin. Imagine a colossal object crashing into Pluto billions of years ago, leaving a massive scar. It's the easiest way to make a giant hole, Denton explains. But there's a twist. This basin's position is unusual. You'd expect such a significant impact to make Pluto wobble and eventually tilt, moving the basin closer to one of its poles. Yet, Sputnik Planitia sits near Pluto's equator. Why hasn't it shifted? Some scientists previously theorized that the impact not only created the basin, but also formed a dense liquid water ocean beneath the surface. The weight of this ocean could have stabilized Pluto, preventing the planet from tilting and keeping Sputnik Planitia near the equator. However, there's a catch. Pluto's surface temperature is a frigid 230 degrees Celsius. Even the warmer interior is likely far below water's freezing point. So how could an ocean survive? What if there was no ocean? Denton and her team used computer models to simulate various space rock impacts on Pluto. One scenario stood out: a 730-kilometer-wide space rock, slightly larger than the asteroid Vesta, with a dense, rocky core. Their model suggests that upon impact, the outer layers of this massive object would vaporize, but the heavy core would remain intact and settle beneath Sputnik Planitia. This dense core could keep the basin from moving, explaining its current position near Pluto's equator. Carver Beerson, a planetary scientist at Arizona State University who wasn't involved in the study, finds this idea intriguing. He notes that many researchers are skeptical about a subsurface ocean on cold, distant Pluto. A new model like this one, proposing a rocky explanation, is a welcome alternative. To confirm any of these theories, we'd likely need to send a spacecraft to orbit Pluto and measure its gravity. These measurements could reveal more about Pluto's internal structure and composition. Scientists have proposed such a mission, but even if approved, it could be decades before it happens. Don't forget to subscribe and hit the notification bell. See you in the next video.